So today I'll be talking about the Lake Sturgeon Index Survey for Lake Superior. This was first conducted in 2011 and again in 2016. And the Lake Sturgeon Work Group developed this survey to be part of the 5-year CSMI rotation on the Great Lakes, as well as part of the Great Lakes Water Quality Agreement. And I'm here to give this presentation on behalf of the Lake Sturgeon Work Group, which consists of members from the many agencies that work on Lake Superior. And my primary role with the index survey has been to coordinate a lot of the field efforts, manage the data, and to report on the results that we come up with. So I do want to mention before I get too deep in this talk that we're still proofing some of the 2016 data, so it's possible that some of these results could change. I believe the last time we presented on the index survey work was here at the Lake Committee meetings was back in 2012. So briefly, I'd like to update everybody on the development of this survey and the goals we set for it back in 2011. Also go over the sampling design and methods we used. And below you can see a map showing all the current as well as expected populations for sturgeon around Lake Superior. And this will be the focus for all the individual status assessments. Also, you can see that I've grouped these tributaries roughly into 3 different regions. This was based off of genetic similarity. You'll see me reference these throughout the presentation. So in response to historical population declines, the Lake Sturgeon Subcommittee developed a rehabilitation plan which outlines specific rehab goals and sets forth management strategies. The rehab plan also recognized there was a lack of some pretty basic information on things such as population size, recruitment, age structure, and age of maturity. In 2010, the now renamed Lake Sturgeon Work Group started the development of an index survey so that we could meet some of these needs which were identified in the rehab plan. For the index survey, we came up with 3 specific goals. The first was to describe the current lake-wide status of Lake Sturgeon. We wanted to focus on ages roughly 4 to about 15, which represent the juvenile and sub-adult stage. And we wanted to look at these age classes primarily so that we could detect the change in anything much quicker than waiting for these fish to become adults. Also, we wanted to establish an index of relative abundance for those same age classes, to monitor recruitment, year class strength, and population trends over time, as well as simply describe and compare the biological characteristics, both within and among populations, and also to see how those would change over time. In addition, the rehab plan also identified other needs that should be addressed, such as the need to develop a standardized lake-wide sampling protocol for sturgeon, the need to assess recruitment of juveniles, as well as assess abundance relative to some of the major spawning tributaries, as well as the index survey is working towards coordinating the collection, analysis, and reporting of biological information on Lake Superior. We're also working to establish a uniform marking and tagging database among all those agencies, and also working in conjunction with the Great Lakes Lake Sturgeon Tag Identification Database. So as you can imagine, trying to carry out the lake-wide survey on the scale of Lake Superior definitely requires a cooperative effort. So here you can see all the agencies that contributed to this effort, not only in 2011, but again in 2016. And these range from Canadian, provincial, and federal agencies to state and federal agencies on the U.S. side. I can't emphasize enough the importance that tribal and First Nation natural resources departments played in carrying these surveys. We also had help from 2 different universities. So prior to any field sampling, and in an effort to standardize and coordinate this effort among all those different agencies, I sent out 3 main documents prior to the field season. The first is a written protocol that details all the procedures that field crews need to follow. Secondly is standardized data sheets, and also fixed gillnet site survey coordinates for the field crews to deploy their nets at. Also, we hold a conference call to get everybody on the same page with what they're doing. The Fish and Wildlife Service also received funding from the EPA for the CSMI project to purchase equipment such as nets, pit tags, tag readers, and coated wire tag detectors. And this equipment was distributed to the agencies as they were needed. The sampling design that we used was a stratified random design where we proportionally allocated more sampling effort closer to the tributary mouth. And this was based off of some previous sampling where we detected higher concentrations of lake sturgeon closer to these spawning tributaries. So for each location, we set a target of 16 gill nets per location, where 6 nets were allocated to the inner strata from 0 to 2 kilometers. 6 nets were allocated to the middle strata from 3 to 5 kilometers from the mouth, and the remaining 4 nets to the outer strata at 6 to 10 kilometers. The gill nets we used were 1,000-foot monofilament gill nets, and they consisted of 6 different panels, with the first panel being 300 feet of 4.5-inch mesh, followed by 100 feet of 8-inch and 100 feet of 10-inch. And these 3 panels repeated themselves to fill up that full 1,000-foot complement. We also restricted all of our sampling to between 3 and 15 meters of water, which corresponds to about 50 feet. And like most fish surveys, we took all the common fish measurements, lengths, weight. Generally, we weren't able to get sex on most of the sturgeon because they were immature. Also, we gave them ploy tags, pit tags, checked for coated wire tags, which might indicate stocking. And all fish also received a fin clip for genetic sampling, and a subsample of them received a fin rate section for age analysis. Here's just a very simple table showing some survey results. We had a slightly higher catch in 2011 with 365 sturgeon, and a little bit lower in 2016 with 310. One thing I want to emphasize is we did have some pretty severe flooding along the south shore of Lake Superior in 2016, which likely impacted our catch results on the Bat, Montreal, and on the Tanagan. I might also throw the St. Louis River in there as well. Also, I do want to note that the Little Pick in the northern region of Canada was first sampled in 2016, but was not part of the 2011 survey. So here I've got a figure showing the geometric mean CPUE with the 95% confidence intervals around the mean of a bootstrap data set. And the first thing that really stands out to me is the high catches that we observed at the Goulet. We're looking at anywhere from 5 to 6 fish per 1,000-foot gill net, which is a lot higher than most of these other locations. Kind of on the contrary, there's 3 locations where we didn't detect any sturgeon in either years. And those are the pigeon, the nipigon, and the gravel. Additionally, we had a couple other locations where only a handful of individuals have been caught. And that includes the north entry of the Sturgeon River, the Kaministiquia, and the Tequamanon. One thing I just talked about real briefly was the flooding along the south shore. And you can see we had a little bit lower catches at some of those tributaries. I do want to note, though, that the only significant change in catch between the 2 years was found here at the Ontonagon. And this could very well be due to the timing of stocking events that have occurred there, not necessarily related to the flooding. Here's a figure showing the size distribution of lake sturgeon for all the tributaries where we caught them. And while it initially appears that there's a lot of changes going on here, based off a Kolmogorov-Smirnov test, the only significant change in the size distribution we saw was here at the Bat. Again, this possibly could be due to some of the flooding effects hampering our sampling. But I don't want to put a whole lot of stock in this figure right now because we've only got 2 years worth of data, essentially. So trying to decipher anything that's biologically meaningful out of a figure like this, probably a little bit early. This figure shows the length-weight relationship, which is summarized by region. And so what I've got here is 4 length categories: 500 millimeters, 700, 900, and 1100 millimeters. So what I did was I plugged these lengths into the length-weight relationship for each region. And what we see is for the sturgeon in the eastern region at 500 millimeters tended to have just a slightly higher predicted weight than the other regions, although this was not significant. But as these fish grew up to be 1100 millimeters, we see that the predicted weight is basically the same for all regions. So this really was an indication that the length-weight relationship really didn't change among the different regions. Here's a figure showing the mean length at age, and again, these are summarized according to region. And one of the points that I want to make here is, for fish that were less than 10 years old, we were able to get some pretty good aging data off of them. But for fish that are older than 10 years, you can see how these lines get pretty squirrely, indicating that there's likely age estimation error. However, I'm not sure that we're really concerned about this too much because the targeted ages that we're going for with the survey are generally these younger fish. So one of the things that I'm hoping to do with this age data is possibly develop an index of recruitment by looking at group 5-year cohorts, meaning we'll take the count of fish between 5 and 9, for example, and then using that as a measure of recruitment as we go through these 5-year periods for surveys. Here I've got a map showing the 2011 genetic assignments. Right now we're still in the process of working through the 2016 genetic samples, so I don't have that data quite yet. But this might be one of the most intriguing figures I'll show you today. And so what I've got here is a pie chart showing the tributary assignments for each location. And what I've done is I've grouped sturgeon into, I guess, 5 categories. The first category with this light purple color is unassigned, meaning fish had an assignment probability of less than 0.8, meaning there's a lot of uncertainty as to which source population those fish belong to. The dark purple represents Lake Huron. Generally these fish came from northern Lake Huron, the York Channel area. And then the green shades, the first category I've got is tributary in dark green. And this refers to fish that were caught at the mouth of one tributary and genetically assigned back to that same tributary. The regional category describes fish that were caught at one location but assigned to a different tributary but within that region. And the interregional category, the lightest green, refers to fish that were caught at one location but assigned back to a source population in a totally different region. One of the things that struck me most about this figure is the high proportion of unassigned fish. And it was probably most evident on some of these Canadian tributaries. One of the explanations we came up for why this could have happened is some of the source populations along the Canadian shoreline haven't really been described very well as far as their genetics go. So we don't have a good baseline for which to compare some of these fish to. Also, you notice for this tributary category, probably some of the higher proportions kind of fell out along the south shore here, even like here at the Pick White. But I think what was most interesting to me is that this interregional category, at some of these locations we saw anywhere from 5, 15, even up to 25% of the fish fell into this category, meaning they're long distance migrants coming from a totally different region. And this was particularly interesting given the high level of genetic diversity that we see in some of the source populations for this period. So after the 2011 survey, that was our first year of conducting this brand new survey. We wanted to make sure that we could actually accomplish our objectives. So here I've got just a real quick evaluation. The first figure showing the size distribution by mesh size. And what you'll notice is that most of the fish that we caught fell into this 500 to about 800 millimeter category. And this corresponds back to fish in the ages roughly 4 to about 10. Again, those are the ages that we got the best data from. So we weren't able to effectively target the ages that we were going after. Also, we went into the survey with a design where we proportionally allocated more effort towards those survey models. So to evaluate whether that was a good idea or not, here I conducted a mixed model to compare CPVs among those different strata. And what we found is that catch per unit effort for the inner strata was significantly higher than it was when compared to the middle or the outer strata. But when we compared the middle versus the outer, they were statistically similar. So this gave us a little bit of a justification for how we allocated our effort. So where does this take us in the future? Right now, we need to process our 2016 genetic samples. And I already mentioned that we should probably look in a little bit more to improving some of the genetic baselines for some of these source populations, especially along the Canadian shoreline. That can hopefully reduce some of the fish that fall into that unassigned category. Also, I did mention that I'd like to develop an index of improvement, possibly on grouped 5-year cohorts. I think that'd be valuable for the survey. And also, I think we need to do a better job of working to evaluate all the data we've collected to better describe the status of these populations. How are they doing? Good, bad? Are they increasing, decreasing? What are they doing? And while we're only in essentially the second year of this survey, I think the value of the survey will be seen as we add a couple more data points to these graphs. Looking forward to next winter sometime, we hope to have at least a report put together from this data, kind of publication. And the 5-year cycle has seemed to work pretty well for us on Lake Superior. So I think we'll probably try to continue on that, which would put us in 2021 for the next round of lake-wide sampling. However, there's a couple locations around the lake where we may do this on a more annual basis, such as St. Louis, Ontonagon, and even Boone. So we've got a little bit of time. I'll take the question.